Oh, I didn't even realize what time it is. It's calculus time. Today we will be learning about the marvelous man, Michael Rolle, and his contributions to calculus. Let's start with a short history lesson. Rolle was born in 1652 in Amberville, France. I'm not gonna lie, I had to look that one up. Rolle was the son of a simple shopkeeper, and as was common of the age, only received an elementary school education. He married at a young age and had to overcome financial hardship while also pursuing a career in mathematics. Everything changed, however, when he published a beautiful solution to a previously unsolved problem in Diophantine analysis. The simplest definition of a Diophantine equation is an integer solution in a solution such that all the unknowns take integer values. In other words, he, an unaccomplished mathematician, had officially made a name for himself. After that, he became one of the few teachers at his elementary school to receive payment, and went on to solve another difficult mathematical problem, this one by Jacques Zenon, another famous French mathematician, known for his logarithmic and trigonometric table discoveries. Now, what all of us have been waiting for, Rolle's theorem, which is pretty similar to the MVT. His theorem goes something like this. Any real value differentiable function that has equal values at two distinct points must have at least one stationary point somewhere between them, which is a point where the first derivative is 0. Now I'm going to show you a calculus problem using Rolle's theorem. I interrupt this message to bring you a quick math joke. Why did 7 eat 9? Because you're supposed to eat 3 squared meals a day. Yeah, I'll squirt myself out. Let's take a look at our first example of Rolle's theorem. So we're given that y equals x cubed minus 4x, and we're asked to find a value in the interval of -2 and 2, which satisfies Rolle's theorem. Our first step is that we have to verify that Rolle's theorem can be applied. So we calculate that the function at -2 and the function at 2 is 0. And we calculate that the function is continuous and differentiable. Then we take the derivative of f of x, and we get 3x squared minus 4. Now we know that there must be at least one value of x between -2 and 2, for which the derivative of x equals 0. So we set 3x squared minus 4, which is the derivative of x, equal to 0, and we solve, and get x squared equals 4/3, which comes out to be positive or negative 2 square root of 3 over 3. So, in conclusion, there are two values which satisfy Rolle's theorem. Most of us have heard about Rolle's theorem, but he's also famous for his traité d'algèbre, which is his theory of Gaussian elimination, basically row reduction for matrices, and his critique of infinitesimal calculus, which was a well-formulated hypothesis but was eventually proven wrong. All in all, Rolle contributed a lot to modern mathematics and achieved greatness from humble beginnings. He was a pretty cool guy who contributed to modern calculus by the means of his theorem and developed the algebraic method of substitution, and unfortunately passed away on November 8, 1719. Thanks for tuning in to my presentation on Michael Rolle.